The field of robotics is a category of technology that applies to nearly every manufacturing, distribution, and service industry. A section of robotics, including automated guided vehicles, AGVs, and autonomous mobile robots, AMRs, are all constantly in motion, which means that they are subject to extreme environmental conditions not present in many other robotic applications. The electrical subsystems must be tolerant of these conditions. That includes the cable and board connectors that are used to interface the various power, sensing, and communication components.
Welcome to today's Tech Chat, sponsored by Mouser Electronics, where we chat with engineering experts about the latest technical innovations that are shaping and reshaping our world. Today, we are excited to chat with Jeff Combs, Assistant Vice President at Hirose Electronics, to discuss advancements of products in some pretty interesting modern evolving applications. Welcome to the Tech Chat, Jeff.
Yeah, thank you very much, David. So today we'd like to talk about technological advancements in robotics, particularly focusing on the AGV and AMR applications. Quick agenda for our talk today. First, we'd like to kind of define what AGV and AMR means, at least in the context of discussion today. Some market overview about where we see the growth for AGV and AMR in particular, and the new technologies that are expected to be applied and influence design considerations for these products. As well as kind of a key component breakdown of the AGV and AMR systems, with a highlight of three potential issues, things to consider when designing an AGV AMR system, with some suggestions on some Hirose products that may help solve those problems and facilitate more advanced designs. So to kick it off to, what is an AGV and AMR system? And we're looking at AGV as an automated guided vehicle. In this case, it would be a robotic system that generally runs on a track system, such as a magnetic tape in the floor, usually used in warehouse environments to move materials from one place to another, versus an AMR, autonomous mobile robot. Again, autonomous being the key word here, has some ability to be able to automatically calculate a route to a preset destination. And also maybe have some additional functions that allow it to either interact with humans or the environment, manipulate the environment, particular robotic arms and other functionalities added to it.
Now, really quick, Jeff, I do have a quick question about that. Just on the application of AGVs and AMRs, I know you mentioned warehousing and logistics as being a popular application for those, but have you also seen those kind of trends also in like healthcare service robots at hospitals and even kind of cropping up into general service industries? I've seen some ideas like food delivery for AMRs, things like that.
Yeah, we're kind of looking at it initially from this smart factory / warehouse environment. But to your point, a system that can do something in a smart factory, a system that can move materials in a warehouse could easily be applied to other markets. And I think you're going to see a blurring of the lines on where those systems are applied. So an AMR material mover in a warehouse might easily transition to an outdoor autonomous delivery system. Again, not sliding to the right and just applying as is, but those technologies can be applied to a lot of different markets, to your point.
Yeah, and definitely the products that you're talking about, they're applicable to the AMR system, regardless of really what the application area is.
Yeah. And from Hirose's technology, from connector standpoint, we have to be conscious of the end application and what it needs to do. But generally speaking, the people designing the product are going to take it in that direction. And the functions may be very, very similar from a hardware component standpoint. And so we're going to try to address and help facilitate those functions, and then how those functions are applied may be up to the considerations in the design for the end application.
Sure, absolutely.
I think everybody has a general understanding that this may be a growing market, but there's key factors that are driving the acceleration of the adoption of AGV and AMR applications in various environments. E-commerce being one obvious one in warehouse environment. Maybe some fallout from the quote unquote Great Resignation. Other drivers that are accelerating the shortage in labor, and so movement toward leveraging autonomous or semi-autonomous systems to kind of take up the slack from direct human interaction. Increased design and use of a smart factory, and then our what everyone may still have on their mind a little bit here, COVID-19, factory lockdowns that may put these factories in an environment where they need to operate with less manpower, touchless interactions, and then maybe even more toward home delivery acceleration. So in 2020, we're looking at around 2.5 billion for the AGV AMR market, and in 2026, we're expecting a 6x growth to 15 billion. So a growing market, and a market that has a lot of new emerging application opportunities. So a lot of new designs are going on here that are creating certain challenges. As far as a general technology roadmap for the AGV AMR market, we see certain trends emerging here, moving more toward autonomous operation with the transition from AGV to more AMR applications. All of these are being done kind of in a context of moving toward newer form factors, particularly more streamlined form factors. That's in the context of also adding a lot of new functions to these systems, particularly when you make the transition from an AGV to an AMR. And these functions might include, to achieve more autonomy, additional sensors, and also more Wi-Fi or more remote connectivity. Longer run times are also required, which puts more emphasis on more battery capacity and the power supply issues entailed in that. This puts some unique requirements on the hardware components, and from a connector standpoint, we see more needs for waterproofing, obviously small size form factors, higher reliability ratings, higher temperature resistance, vibration resistance. All of these sensors and some of the connectivity schemes also are going to require higher speed transmission. And with that comes concerns for EMI and noise suppression, right? All of this leads toward a need to consider not only the end function, but then also the modules that facilitate that and the hardware components that facilitate the modules. So something to consider moving forward in the hardware design space for AGV and AMR.
Now, I know that a lot of technology behaves pretty similarly in its evolution of moving from less advanced to more advanced, but I see certain trends of similarities between all technology where connectors need to be able to really, if we could just kind of generalize, it's facilitating more durability and ruggedness, higher data, both rates and density. You mentioned lots of sensors that have evolved onto these machines, and then also the ability to withstand higher power transmission. So power, data, and the durability and ruggedness are kind of three main things that it looks like are really emphasized throughout all of these characteristics that are on these connectors.
Oh, definitely. And sometimes that might be, looking at it from a particular module to module connection, or, looking at it from the connector perspective. That could be a power supply connector that needs to deal with higher power supply issues, maybe in smaller form factors or unique routing environment situations there. Or, as you mentioned, more modules in close proximity at higher data rates really raise the concerns about EMI. So mitigating that is another big issue. And each one of these, issues might be encompassed in one particular connector, or it might be ganged into a similar connector, meaning high data rate, EMI, and some power supply might need to be facilitated by one system, or it could be divided into several systems. So it's pretty complex environment with a lot of moving parts when considering the design of these systems here.
And that certainly speaks to why there's not just one connector designed. It's a universal that works for every application.
Yeah, that would make our job easier, but it's fun to approach these challenges, as you mentioned there. So.
Absolutely. Now, do you have any examples of like a physical AMR AGV system where we might see some of these subsystems and connectors being used?
Yeah. So here's just kind of a quick blow up of maybe three key subsystems that we see within the AGV AMR environment. One would be the power train, which would include the battery and then the motors for moving the system around. The next would be kind of this the sensor array to allow more autonomy. That would include like LiDAR, radar, all the requisite cameras that help the system understand its environment and move within it. And then the connectivity, all of the wireless modules, whether that's Wi-Fi, cellular, 5G included, as a third subsystem. But again, there's definitely that trend of more subsystem modules going in there. You have a lot of options for wireless connectivity, and you may be using some or all of them. You have a lot of sensors and or cameras required to make a system an autonomous vehicle. You've got higher power requirements and in the powertrain included. And as mentioned, all potentially in a shrinking form factor. All of these things are becoming closer together. And the space savings, the data rates, and the EMI concerns included in that type of environment definitely have to be addressed in the designs. For now, I'd like to kind of address three example issues when considering designs for AGV AMR. One would be space savings. One would be considerations of the reliability of your components. And the number three would be signal integrity and EMI considerations within a dense system. So for number one, space saving. As mentioned, more modules are being placed in a shrinking form factor to facilitate particular AMR applications. In this case, we'd like to highlight one of our wire-to-wire or wire-to-board subsystems that helps facilitate much smaller form factors. So Hirose has a nice lineup of wire-to-board or inline wire-to-wire connectors with power supply capabilities from 4 amps up to 65 amps in small form factors. I'd like to highlight one particular system, which is our DF63. It's an inline wire-to-wire system that supports 14 amps. It's also IP67 rated. And this has some potential novel application usage, particularly in routing through an AMR subsystem. Okay, so in the example of an AMR system with robotic manipulator, you have a challenge where you need to route power from a battery system up through various points in a multifaceted manipulative arm structure. And every one of those points has got motors and other things that require power. So the ability to route from the battery up through the system, initially it might start in this more box-shaped, the body of the AMR, but then it's got to start going through potentially very narrow, constrained spaces in the armature. And this, may also be further constrained with hinges and other joint points through the entire portion of that system. The DF63W, as mentioned, is inline wire-to-wire system. At 4 positions, this system will be able to be routed through an 18 diameter aperture, which is industry leading in its small form factor. And again, this system does support 14 amps in its power supply, so that's a very small space with a relatively high power supply. There's also some unique features in the DF63 that helps make that routing and usage through tight spaces, even better, and that includes kind of a smooth contour on the outer portion of the connector jacket. You're not going to hang up on anything. It allows smooth routing through the system. There's also no metal exposed on the unmated and mated configuration of the system, so mitigate issues and concerns with touching some metal causing some shorting either during assembly or after mating. This again allows for power supply in a inline wire system through tight spaces, and those tight spaces, may start in a smaller body, but get exacerbated when you're going through a very, very tight hinge and kind of that convoluted wire flow from a multifaceted armature structure, starting at the body all the way through to the end of it. So this will allow more complex robotic arms or other applications to be achieved and still get it the power to operate that it needs.
And as far as that high current capacity that you mentioned, I just know from experience in working with many robotic systems, especially recently, there's a lot of developments in electrically actuated end-of-arm tooling, including even like pneumatic vacuum grippers, where the vacuum is generated at the hand rather than running pneumatic hoses through the arm. And those can consume quite a bit of current. So that high current capacity and high data density is definitely on the rise for those robotic end-of-arm tool applications.
Right. Yeah. And again, the vacuum there with the power, it can do its job. But then the trick is it's got to get the power. And if it's on the end of a long chain of link points through a multifaceted armature system, that can be a challenge. You got to be able to route that and get the power to the vacuum for it to do its job. And that's kind of where we looked at trying to give a value add to solve what we believe is going to be an increasing problem, to your point.
Yeah, I absolutely agree. It will continue to increase very quickly.
So next issue would be considerations of reliability in your subsystems. As AMRs potentially move from controlled warehouse and or factory environments and might be used more independently, more autonomously in external, outside remote delivery, other harsh environment situations, puts a stress on the components as far as supporting more vibration and higher temperature capabilities. So Hirose has a nice lineup of multiple flavors of board-to-board connectors. These board-to-board connectors are quite often used with multiple sets connecting the same two boards. And without sufficient either mating guide functions built into the connector system or some ability to float, the SMT, the pick and place and SMT process tolerances might inherently put some pressure on the two connector systems or multiple connector systems and or the two boards just by mating them. And that's even before we talk about a rugged environment. So I'd like to highlight one of Hirose's connector system, the FX26, which is a board-to-board system at 1 millimeter pitch. So in a harsh environment, and this would be kind of addition to just the SMT and board assembly process. On top of that, now we have the use in a more rugged environment. Vibration may cause some shaking and amplitude changes in the two board-to-boards. This could put some stress on the connector and the board, the SMT joints as well, but one consideration would be that Z movement causing some stress on the two connector contacts and potentially scoring or damaging gold plating and either opening you up to corrosion issues and or signal integrity issues.
And those pictures may look a bit exaggerated in that curvature, but I think everybody can think of example sidewalks in their city with delivery robot that has to navigate. Those environments can be pretty harsh.
Yeah. And obviously this is a diagram of the situation, but there might be some really extreme examples where we see something, but no, this is, yeah. So the FH26 board-to-board system allows 0.7 millimeter floating function in all directions. This will allow it to absorb those vibrations without putting stress or any damage on the contact-to-contact points in the two pieces of the system. Again, this will allow you to do multiple board-to-boards on the same board connections, absorbing any of the SMT pick-and-place tolerances, as well as supporting high vibration environment usage. In addition to the floating function for FX26, it's also rated up to 140 degrees C. So that puts it well within some more extreme environment usage capabilities. The last point we'd like to highlight, again, particularly moving toward AMR, more modules. And by modules, we mean the cameras, LiDAR, radar, and also wireless connection to facilitate more autonomous movement in the AMRs. They're all coming into closer proximity of each other, and this, as well as the data rates rising for all of these subsystems. So you have this perfect storm to have some really high concerns on the signal integrity of the connections, as well as mitigation of EMI in the overall system. So Hirose has, again, a lot of flavors of inline wire type connections that are optimized for higher speed data transmission, as well as superior noise resistance capability. So we'd like to highlight one of the systems, GT43, which is a coaxial wire to board or coax to board connection system with integrated shield functions that supports data rates up to 3 gigabps or at the 3 gigahertz range.
And as you mentioned, especially vision type systems, whether that's camera, LiDAR, I know that's even in machine vision systems, that's an advancement, because not only do you have higher frame rates, just pictures being taken at a much more rapid rate, but those pictures are also getting much more higher quality. So both the data and the speed, which is why both of those, you said that that's that perfect storm, because to get that accuracy of environmental sensing for an AMR, you have to have continual camera frames being taken, and then that transmission happening with much higher quality pictures as well.
Oh, definitely. And, you can look at it module by module, but eventually you're going to have to look at the entire system, especially when multiple, let's say, connector, LiDAR, or other modules may then be creating enough EMI to interfere with your either cellular or other type of wireless connectivity. So suppressing the emissions from those higher data rates also becomes very, very critical. Okay, so as mentioned, EMIs are a big concern in these systems because of the increase in modules, but then those modules, as you mentioned, David, have a stress on higher and higher data rates and continual higher and higher data rates. The GT43 system is a coax system, and a little bit different than some of the maybe industry available, single coax connector, coax to board type connectors. The GT43 has an external shielding system on the receptacle, on the board mounted receptacle, allows for continual connection between the outer conductor in your coaxial cable to provide superior grounding capabilities. In other words, signal and your ground are kind of integrated into the system, and as noise travels down the cable, it effectively contacts into the receptacle shield structure and grounds to have superior noise suppression capability. To kind of recap, AGV AMR, I think we all recognize that there's a lot of growth potential for these applications. With the growth potential comes some challenges, space savings being one of those, where systems are shrinking but functionalities are going up and the overall component space is shrinking. We highlighted the DS63 wire system to help facilitate power connection through small spaces, particularly AMR, robotic arm armatures. There's also the reliability concerns in harsher environments. We discussed the FX26 and its high vibration support capabilities. And then as we move toward more sensors, particularly in AMR applications, data rates are going up. The space between modules is shrinking. So the support for higher signal integrity requirements, as well as EMI concerns, is increasing. And we talked a little bit about Hirose's GT43 system, which would allow superior EMI suppression using integrated receptacle shield structures while supporting 3 gigabps data rates. These are just a few examples of a broader catalog that Hirose provides, but we're very interested in talking to you about your AGV and AMR design concerns and to work with you in providing some solutions to facilitate your vision of the design for your product.
Before we sign off, I want to encourage everyone to check out all the latest Hirose electronic products at Mouser Electronics, our sponsor for today's Tech Chat. And special thanks again to Assistant Vice President Jeff Combs. Please join us again next time on Tech Chat, where we chat with the leading technical experts like Jeff who are changing our world every day.